Okay, so by now you should know how we make alkenes, how an alkene varies from an alkane, and how we can produce smaller alkenes by cracking. And so that leads us nicely onto the topic of polymers. Poly anything just means lots of. And here we are talking about small units, or in this case, in this video, we're going to talk about alkenes. But any small unit which is going to make up a massive chain is known as a monomer. So we have a monomer, which is a small subunit, and loads of those put together will give us a polymer. Okay, so polymers are extremely important in nature and also in terms of technology for us. So an obvious one that we can actually produce using alkenes is a plastic. We see plastics all the time. There are loads of different types of plastics, but those plastics are normally made by alkenes or something similar to an alkene joined together and making a massive long chain molecule of smaller subunits. And so as an example, a monomer might be something as simple as ethene. Ethene, okay? We imaginatively give the polymer the name polyethene. And in general, the polymer is separated with these brackets. So we have poly, and then we have the monomer in these brackets. Often you won't see those on shop labels and things like that, and you might have heard of just polythene. So of course things like polythene bags and everything else, that is actually polyethene. Polythene is a more common name. You can also hear it as polyethylene, and it's the same thing. But for us, in terms of chemistry, we're just going to write the word poly and then put in brackets the name of the monomer. So what if I had butene and I polymerized butene? Take a second to have a guess as to what the name of the polymer would be. And hopefully you wrote down or just thought in your head polybutene, because butene is your monomer there and polybutene would be your poly. Okay, so that's all well and good, knowing what the names are and everything else, but how do they actually join together? Well, there's a very simple diagrammatic way of explaining it, and then I'll go in a bit more complicated. So if you can think of ethene, if we had gaseous ethene, there would be loads and loads of ethene molecules all buzzing around like this, okay? All of them separate, each dot represents ethene. And so all of them are separate and they are just buzzing around doing their own thing. Now that would be ethene. Polyethene would be taking all these dots and putting them in a straight line, like so. So loads of those dots all bound together would give us polyethene. And so of course let's have a look in a bit more detail. If you remember from the previous video, ethene looks something like this. So we have carbon double bound to another carbon, and then each carbon can have how many bonds? Well, 4, and we have 2 bonds in the carbon-carbon double bond, and so we have 2 extra bonds to these 2 extra hydrogens on each side. Okay, what we are going to do when we polymerize ethene is we are going to break this double bond. If we break this double bond, but we don't add any more hydrogens, then what will this look like? Well, if we break the double bond, we'll only have a single bond. There we go, so we break the double bond and we only have a single bond. But we haven't added any more hydrogens, so we have 2 hydrogens to each carbon. And the reason I've drawn the hydrogens above and below is because, well, carbon can bind to 4 things. In this case, it is only bound to 3. So carbon, hydrogen, hydrogen, carbon. Well, where's the 4th bond? It hasn't got one. So we have a spare bond. And the same goes for this carbon. We have a spare bond. That means that something can come and bind here, and therefore we can extend this chain. And now think, if we did exactly the same thing, so we did exactly the same thing like this, we have another ethene which has been broken open. And now look what happens if we put the 2 together. We put the 2 together, we now have a 4 carbon chain, but we still have these spare bonds on the right hand side and on the left hand side. And so that means I can add another one if I want to. So we have another one here, and look, we can move it to overlap and continue the chain. And so this is actually what happens on and on and on and on and on to produce massive long chains of ethenes all joined together. And that is what we call polyethene. So there we go, ethene looks like this, and once we break open the double bond, add them all together, it's going to look something more like this. And this reaction is known as a polymerization. Polymerization, because all we're doing is we are forming a polymer. So polymerization. But because if we're going to write a chemical equation, let's say for example we added together about 1,000 monomers. It may be 1,000, it may be slightly less, it may be more, who knows. But let's say hypothetically we had 1,000 monomers. We do not want to write an equation where we write this 1,000 times and add them all together. And so the way that we get around that is that we draw the monomer. And if you remember, the monomer is what we start with, which is ethene. Drawing it like this because this makes it easier to see where we are going to open up this double bond to, eventually here and eventually here. Get rid of that. But we say this n times, okay? So n lots of this. Remember, n can be whatever we want. N is the number of these that we're going to add together. In this case, I said it was going to be 1,000. And so that is going to give us the polymer, which is carbon, hydrogen, hydrogen, single bond, carbon, hydrogen, hydrogen, okay? Bond that way, bond that way. We put it in brackets because this is the smallest unit of the polymer. This is what we started with, and this is what that has ended up as. So we're going to have this monomer within the polymer n times, because n times this is going to be bound to another one. So remember I said 1,000. If we have 1,000 of these, if we crack open this double bond, it's going to look like this. So a long chain, as we had up here, but 2 carbons and 4 hydrogens are going to be present 1,000 times. So this n just means times this by 1,000, and that is our polymerization reaction. That obviously saves us a lot of drawing and a lot of time, and it is also extremely clear where everything has come from. Now I'm just going to quickly show you one more example, because a lot of people might think, well, all there is here is exactly the same thing, just loads and loads of times. So why are we drawing it like this? Why don't we just draw a bracket around 1 carbon or 3 carbons or whatever, because it's all the same thing. If we had something which was slightly more complicated, for example, what if we had the same thing, ethene, but we replaced one of the hydrogens with a chlorine. Now, if we bound this together n times, so n lots of these, we are not going to get just what we had up here with carbons and hydrogens. There is going to be a chlorine. But remember, the chlorine is only going to be on every other carbon, because this carbon here doesn't have any chlorines on it. So the chlorine is going to be on every other carbon, so we have to show the entire monomer in order to make it clear. So we would have something that looks like this. We'd have carbon, carbon. This carbon doesn't have any chlorines on it, it just has 2 hydrogens. But this carbon has a chlorine on it, okay? And then the same thing, these combined to more of exactly the same monomer n times. And so that really does clarify what your monomer is and what your polymer is. So where you've come from, which is this starting molecule, and where you finish, which is this final polymer. Right, so I hope that's cleared up the basics of polymers and polymerization. Please have a look at my later videos where we'll go on to discuss specific types of polymers, why they're useful and where they are used. So as always, please do write a comment in the box below if you have any questions, and I'll see you in the next video.